20 million. That was the number cybersecurity experts have been watching. The number of quantum bits or qubits needed to crack the encryption that protects your bank account, your messages, and basically the entire internet. Well, Google just slashed that number to under 1 million qubits. That's a 20-fold reduction, and it means the quantum threat to our digital security just became a whole lot more real. But here's the thing, this breakthrough isn't just about breaking encryption. It's about what happens when we can finally build these machines. Let me explain what we're dealing with here. RSA encryption is everywhere. It's the mathematical lock that keeps hackers out of your online banking, protects your credit card transactions, and secures government communications. The way it works is actually pretty clever. It relies on the fact that while it's easy to multiply two large prime numbers together, it's incredibly difficult to work backwards and figure out what those original numbers were. Your regular computer would need thousands of years to crack a 2048-bit RSA key, but quantum computers, they play by different rules. Back in 1994, a mathematician named Peter Shor figured out that quantum computers could factor these large numbers exponentially faster than classical computers. The catch was that you would need a massive quantum computer to do it, and until now, estimates suggested you'd need about 20 million qubits. So what changed? Google's researchers found three major breakthroughs. First, instead of doing exact calculations, they realized you could use approximations that are good enough for factoring. Think of it like this. If you're trying to hit a target, you don't need perfect aim, you just need to get close enough. This approximate approach dramatically reduces the computational overhead. Secondly, they developed better ways to handle errors. Quantum computers are incredibly fragile. They're like trying to perform surgery during an earthquake. Google developed something called yoked surface codes that can store quantum information about 3 times more efficiently than previous methods. They also created magic state cultivation, which is a more efficient way to generate the special quantum states needed for these calculations. Third, they broke down the massive computation into smaller, more manageable pieces by using something called residue arithmetic. Instead of trying to solve one enormous math problem, they split it into many smaller problems that are easier for the quantum computer to handle. The result? Their new estimate says you could break 2048-bit RSA encryption with less than 1 million qubits, and it would take about a week to do it. Now, before you panic about your online banking, we're still probably about a decade away from building quantum computers this powerful. Current quantum computers only have hundreds of qubits, and they're nowhere near reliable enough for this kind of sustained computation. But here's why this matters. It's not just about when these quantum computers will exist, it's about when we need to prepare for them. Cybersecurity experts are already pushing for a transition to post-quantum cryptography, which are new encryption methods designed to resist quantum attacks. The US government is recommending that vulnerable systems be phased out by 2030 and completely replaced by 2035. This research doesn't just bring us closer to breaking current encryption, it brings us closer to the quantum computing revolution itself. The same techniques that could crack RSA will also accelerate drug discovery, optimize supply chains, and solve problems we can't even imagine yet.